In the second example for rectangular coordinates, we have two trajectories for x and y, and this is about the motion of a particle in two-dimensional motion, that means in plane motion. And the coordinates are given in millimeters, and they are calculated as a function of time for both of those x and y trajectories. And the t here is in seconds, and well, what we are asked to do is to find the magnitudes of the velocity v and acceleration. That means we need to calculate x dot and y dot, and then take the squares of them and add them up, and then take the square root, and that would be the magnitude of the velocity vector basically. And x and y are already as functions of time, so it's easy to take derivative of them with respect to time. And this calculation will happen at time equals to 3, so t, instead of t, you will substitute number 3 for the as a value of 3 to the equation, and then you will find the magnitude of the velocity, which is basically speed. And the same thing in same idea is true for the acceleration. Finding the magnitude of the acceleration, well, we need x double dot and y double dot. Take the squares of these, square root of that will give us the magnitude. In any calculation, for the calculation of the square root, you have a plus minus, but then this is a magnitude, it always have to be plus, so we don't have that for these square roots, by the way. And another thing that is asked is the angle between these two vectors. Now that's interesting. The other part is basic differentiation, so you can derive these with respect to time and find out that x dot will be just 2t minus 4, and then take the second derivative, it will be 2, so it's not very interesting, but the other part is a little bit interesting. There's a vector of velocity, let's say this is the vector of acceleration at any time, okay? And we are asked to find the angle between these two vectors. And how you do that is, you should remember your vector, and you can calculate for this, and for that, the dot product, the projection, would give us the information about the angle, and that information is a times v, the magnitudes, times cosine theta. And from here you can find theta as arc cosine of a dot v over the magnitude of a times the magnitude of v. And this is how you would find it for any value of time. This is the case for time is equal to 3 seconds, and there's your result, which is 11.67 if you do the necessary calculations. Okay, so this was a little bit easy question, but just to remind you guys some vector algebra. Now in the second question, well, this is a test setup basically. This setup is to test the bearings, how they bounce, and then you can find out the irregularities about these bearings in this test setup. It's a nice question in that sense. Now we have this heavy plate, that means this plate will not change its direction. This is something that we're going to study in the next parts of this course about impulse momentum. However, this is heavy plate. You can take it as a fixed earth. It's not going to move. What moves is this particle, the bearing, hits the ground and then picks up and then moves. Now, if you say this is the y-axis and this is the x-axis, okay. Along the x-axis, for the motion of this bearing, there is no resistance, no force acting on it. So whatever the initial speed of the bearing at this point or that point or after at any point, it will have the same speed. So Vx is basically constant. That we can see. Now, other than that, let's take a look at the bearing in the y direction. Now in the y direction, at this point, you would know that at this point Vy will be equal to 0. The y direction speed will be equal to 0. And it's gonna drop the speed from an initial speed as it picks up from the ground. Okay, and the way that it's going to decrease is due to the gravity. Basically, the gravity is in the downward direction, and the gravitational acceleration is 9.81 meters per second square, and that means in this 500 millimeter of distance, it will drop from some initial velocity to 0, and the acceleration is 9.81. So which formula should I use? Now the choices are ds over dt is equal to velocity, and then dv over dt is equal to acceleration, or ads equals to dv. Which one should I use for this solution? For the Vx part, I can't do much because, well, I know the distance, this is 400, and Vx is constant, and as a result of that, 400 millimeters will be equal to Vx times time. That's good, but I don't know time. I could find time because I know that this will happen throughout the motion. 500 millimeters in the y-axis will be, this particle will be moving up, and there's this acceleration. But which part should I use at the moment? The thing I don't know is the initial velocity, right? What I know is distance and the acceleration and distance. I know the final velocity, I don't know the initial velocity. So I should use this formula, I guess, right? I got a lot of knowns here, and there's one unknown, and that's the initial velocity. If I can find the initial velocity, then I can use this formula, because now I know how the velocity will change from the initial velocity to the final velocity, which is equal to 0. And I know the acceleration, then I can find time. And then I can use that time to calculate the Vx value, the velocity in the x direction. So step by step, I can use these two equations. Well, actually, this would be the third equation, because this is kind of like the same idea here, right? Anyways, so what we can do is we can say that, well, there's this integration of the acceleration negative 9.81 and ds, and the initial value for that, let's say it's 0 based on our selection of the frame, and final value is 500. This is millimeters, so I would actually write it out as 0.5, so that it's in meters, right? And then on the right hand side, the integration v dv, initial velocity, this is vy, by the way, let's just show that so that we won't be mistaken. This is vy dvy, and the initial velocity, well, we don't know that, v0, and then let's call it vy0, so to be mistaken again, and the final velocity is 0. So here you go, there is only one unknown. If I can write out an equation for this, well, I will show the information about vy0. As I have vy0, then I will use this second equation, and there what I will have is dv integration a dt integration, and the time will be from time 0 to time. The time 0 is the time that it touches the ground, and the other time t is the moment that is at the top. So the velocity will be initial velocity v0y, and the final velocity is 0. I solved already for v0y in this equation. That means the only unknown here is time, t, and acceleration is 9.81, negative 9.81. So I will find the solution, and I get the time. I use it here to calculate Vx. So Vx will be equal to 0.4 over time. 0.4 is the meters for this distance. And as I find Vx and Vy, well, theta will be equal to the arctangent of Vy over Vx, basically. So you have the solution for the numerical values and the example. Please take a look at it from your lecture notes. And if you would again have any questions, you can ask it to me in the lecture hour.